Hello, everyone. We have seen the linear probability model in our earlier discussions. In today's lecture, what we are going to do is to understand how to interpret a linear probability model, right? This is a linear probability model. We are going to see the interpretation of a linear probability model. This kind of interpretation questions you can expect for your examination also from this part. See, linear probability model, there are three things. First, you should understand the definition and also a brief explanation of linear probability model, then the problems associated with linear probability model, and this interpretation part. These are the three things that you need to be aware of with linear probability model. Linear probability model, you will be getting this type of an interpretation problem. This is very simple. We have discussed this while we were talking about linear probability model in the earlier recordings, but it is just to put things in perspective so that it becomes easier for you to interpret these things for the exam. That I thought I'll structure it this way. See here, uh, we are taking the case of an econometric model, which is coming as follows. See, di is equal to beta 0 plus beta 1 mi plus beta 2 si plus epsilon I, right? This is the model that is given to us. What does each of these things stand for? Di stands for female labor force participation. Okay, that is whether a woman is there in the labor force or not. So we have defined this variable as d equal to 1. Okay, if a woman is part of the labor force and d equal to 0 if she is not. Okay, so this is a dummy dependent variable, right? And this mi indicates the marital status of the woman, right? It indicates the marital status of the woman. Okay, and this si it represents the number of years of schooling, right? Si represents the number of years of schooling of the ith woman, right? Uh, so these are the three variables that are considered. So di, it is a dummy variable, a dummy dependent variable. What does this dummy variable stand for? It stands for female labor force participation. It is defined as d equal to 1 if uh, a female is part of the labor force, and 0 if otherwise. Okay, mi is marital status, right? And si is a number of years of schooling undertaken by this woman. So what would be the hypothesized signs of both these variables, both these dependent variables? If you take the case of mi and si, what do you mean by hypothesized signs? The signs that we anticipate. Okay, the signs that we expect to have for these variables. See, for example, when it is when you are taking the case of marital status, especially in the Indian context or world over, you can see that after marriage, you have a large number of women uh, not presenting themselves for in the labor force. So marital status is likely to have a negative impact. So the hypothesized sign of marital status would be negative. The hypothesized sign of the number of years of schooling, what it would be a positive sign, right? It would be a positive sign because as the number of years of schooling and the educational qualification increases, it is quite likely that the woman would be a woman would present themselves would present herself in the labor force. That's the expectation. So that's basically what you mean by hypothesized signs of the dependent variables. Okay. What are the signs that we anticipate? What is the direction of the relationship that we anticipate for these dependent variables? That's basically what we are talking about here. So see, we are not going to deal with estimation here, right? Even for your examination, as I have told, you are not going to be asked to estimate as such. You will be given the estimated results, okay, and you will be asked to interpret. That would be the way in which it would happen, right? So you have this kind of a result that you obtain. This is the result that you have obtained after running the regression. So here, as you can see, di hat is equal to minus 0.28 minus 3 minus 0.38 mi plus 0.09 si. Right? These are the standard errors. These values given in brackets are the standard errors, whatever that is. The sample size was 30, right? R squared value is 0.02 and pseudo R squared value is 0.8. Okay, 0.81 actually. So here, how do we interpret the results? See, first and foremost, what is one observation that we can make? We can say that independent variables, that is marital status and the years of schooling, are significant in the expected direction. Okay, this is what we earlier called as the hypothesized signs, isn't it? The hypothesized signs of these variables were negative and positive, right? So those hypothesized signs, when we do the estimation also, you can see that you get coefficients with the same signs. For marital status, you get a negative coefficient. For years of schooling, you get a positive coefficient. So that's why we say that the independent variables are have estimated coefficients that are significant in the expected direction. Okay. Now adjusted R square. How do you interpret this value of 0.32? In a normal model, 0.32 is kind of a low value, right? The adjusted value, adjusted R square value. However, for a linear probability model, as we have discussed before, in one of the recordings, I have talked about the limitations of or the problems associated with linear probability model, where we have told that the adjusted R square values are unreliable because the dummy variable takes a value between 0 and 1 always, and that kind of poses certain difficulties. So as far as given the fact that this is a linear probability model, this adjusted R square of 0.32 is high enough, right? It is generally said that for a linear probability model, the adjusted R square value cannot be expected to be higher than 0.7. Okay, the maximum value that you can possibly expect for adjusted R square when it comes to a linear probability model is up to 0.7, right? So given that when you say that adjusted R square is 0.32, right, it's kind of a high value. And when it comes to pseudo R squared, right, this is something that we have discussed in the previous recording. I have told that since adjusted R square values are not very reliable, you have another measure that is taken, which is the pseudo R square. Pseudo R square, you look at it is 0.81, which is fairly high, right? It is kind of high, meaning that an average of 81% choices are explained correctly, right? The dummy dependent variable was defined as 1 if the female is part of the labor force and 0 if she is not, right? So what we are saying is a figure of 0.81 for the pseudo R squared means that an average of 81% of these choices are explained correctly, which is actually a very good thing, right? So the overall fit of the model is quite good. Now coming to these coefficients, see, take for example beta 1. What is beta 1's estimated value? It is minus, beta 1's estimated value is minus 0.38. What does it mean? We have earlier seen that in a linear probability model, the coefficients indicate the change in the probability that di would take a value equal to 1, isn't it? That's basically what we have talked about. So coefficient value of beta 1 being equal to minus 0.38 indicates that the probability of a woman participating in the labor force falls by 38 percentage points if she is married. Huh? If the woman is married, this point minus 0.38 indicates that the probability of the woman participating in the labor force falls by 38 percentage points if she is married, holding the number of years of schooling constant. Okay. Here, due to lack of space, I have not written here, but that's something that is to be understood. Similarly, if we try to interpret the coefficient beta 2, right, the estimated value is 0.09. What does it indicate? It indicates that each year of schooling, right, each year of schooling increases the probability of female labor force participation by 9 percentage points. Okay. It increases with every year of schooling. The probability that a woman would participate in the labor force, it increases by 9 percentage points, holding marital status constant. Okay. So this is a simple way in which we interpret the results of a linear probability model, right? So you look for the hypothesized signs, right? Given the variables, we can kind of guess what would be the impact, whether it would be a positive or a negative impact. Once the results are available, you look for whether the hypothesized signs are also seen the same way in the estimated results, right? Look for the R squared value, the pseudo R squared value, interpret these coefficients, right? That gives us a fair idea about what the linear probability model is trying to tell us about. Okay. This is how you are interpreting a linear probability model. For your examination, this kind of results would be given to you, right? The equation, the results would be given to you, and these can appear as questions. Okay. What are the hypothesized signs, right, of the variables? And the R squared value or the adjusted R squared value. What is the meaning of this, right? And what are the coefficient estimates, right? Coefficient estimates. What do they tell us? What do the values of these coefficient estimates tell us? Minus 0.38 plus 0.09. What do they tell us? So you write about these kinds of explanations as we have seen here. Okay, as simple as that. Thank you.